the second group of problems are associated with circles. And so the circle is the points, these group of points that are located equidistant from a given center point. So problem 27 says 7 through 30 says match each center radius form of the equation of a circle with the correct graphs for choices from A through D. So actually let's do 27. Let's just do the whole group here. 27 through 30. So let's look at 27. So we have x minus 3 squared plus y minus 2 squared is equal to 25. So all of the problems we have are circles with a radius of 5, because the radius of a circle is, when you put it in this form, is the square root of this number. The square root of 25 is 5. So that's radius. Now what the coordinates of the center point are where these go to 0. So you can see that if I solve this one for 0, I get x is equal to 3, so 3 minus 3 is 0, and you do the same thing here, you get y equals 2. So what we do is we look for the circle of those choices where the center is at the point 3, 2. Now this is the first quadrant because they're both positive. So we'll look for the one where the center is in the first quadrant. And hopefully you'll look at that and you'll say, well, the first quadrant is B. So it's graph B. That's correct. Now 28 has x minus 3 squared plus y plus 2 squared equals 25. So x equals 3, y equals negative 2 are the 2 points where these go to 0. And that, if we have x equals 3, y equals negative 2, that's the fourth quadrant. And we look on the graph, and C is the circle that is in the center is in the fourth quadrant. Okay, 29, we had x plus 3 squared plus y minus 2 squared equals 25. So where this goes to 0 is x equals negative 3, and where this goes to 0 is x equals positive 2, y equals positive 2. So that puts us this way in x and that way in y. So this is the point, the center. That's the second quadrant. So we look for one of the graphs where the center of the circle is in the second quadrant, which is D. And then finally 30, we have x plus 3 squared plus y plus 2 squared equals 25. So this goes to 0 when x equals negative 3. This goes to 0 when x equals negative 2. That's in the third quadrant. Negative 3, negative 2. That's third quadrant. So we look for the graph where the center is in the third quadrant, which is A. So A is in the third quadrant, and that's the answer. Okay, that's pretty straightforward, right? Okay, next thing is you're given the center and you're given the radius, and you're asked to calculate or show the standard form. So let's just try 31. Well, the center is the origin, so it's actually not in any of the quadrants. It's at the origin, and the radius is 6. So you have x minus 0 squared plus y minus 0 squared is equal to 6 squared, or x squared plus y squared equals 36. Number 34, you have 2 comma negative 2, that's the center. The radius is 3. So as far as the x is concerned, you take the opposite sign of what you have here as the point. So you're going to have x minus 2 squared plus y minus a negative 2 squared is equal to 3 squared. The radius is this number squared. So you can see when this x equals 2 and this goes to 0, that's what that coordinate is. Y equals, when y equals negative 2, this is positive 2, and negative times negative, so those both make sense from the previous. So that is the equation. Now the last grouping here is, given the equation in this form, you have to come up with this version of the form when it's in a slightly different original form. So what you get is x squared plus y squared plus 4x plus 6y plus 9 equals 0. Okay, and what we want to do is get it in a form like this. So the way you do this is you take the two terms that involve x and you put those together. So I'm just rearranging things. You take the two terms that involve y squared is 6y, and then you subtract 9 from both sides. So you get negative 9. So this positive 9 becomes negative 9 when I move it to the other side. Now to find that, we're going to add some numbers on here. We're going to add something here, we're going to add something there. So what you do is you take the coefficient on the x term, divide by 2, and then you square the result. Well, 4 divided by 2 is 2. 2 squared is 4. So I add 4 here, but I also have to add 4 there because we have the additional rule of equivalent expressions. If you add one number to one side, you have to have the same number to the other side. Likewise, we take 6, which is the coefficient in front of the y term, we divide by 2, and we square that. So 6 divided by 2 is 3. 3 squared is 9, so I add 9. So then I add 9 here as well. So what we're left with is x squared plus 4x plus 4 plus y squared plus 6y plus 9 is equal to, well, you add these numbers together, you got negative 9 plus 9 is 0, so you end up with 4. Now, the reason we chose these two numbers, 4 and 9, were so that we could rewrite this as a perfect square. Now, the way you do it is you take this result here, this 2, you bring that down here, and so the way you can rewrite this term is x, and then you take this number, plus 2, and then you square it. And if you multiply x plus 2 times x plus 2 out using FOIL, you get x times x, which is x squared, 2x, 2 times x is 2x, 2 times x is 2x. So you get 2x plus 2x, which is 4x. And then you take the last one, FOIL, 2 times 2 is 4. So that's what I started with. So I take this, which is 3 terms, I break it down into a simpler term where everything's squared. It's called complete into square. And you can do the same thing here. You take this number, this intermediate step, you bring that down, and so you write x plus 3, that number, you square it, and that equals 4. So I'm not adding things to both sides here. I'm just using, just rewriting something as a perfect square. Perfect square means something times something, same thing times itself. So I take x plus 2 times x plus 2, and I have x plus 3 times x plus 3, and that goes backward. So that's in a standard form now. So we can say the center is at x equal -2 and y equal -3. Those are the numbers that make those go to 0. And the radius is 2, which is the square root of that number 4. Okay, I think that's, we'll do one more of those. So let's do 42. So we have x squared plus y squared minus 2x plus 4y minus 4 is equal to 0. So the interesting thing is, notice all the examples, these two numbers are even, and that just, they don't have to be even, but it just makes the calculation easier. So for you don't end up with halves or fourths or something, fourths. Okay, so first step, group together the x terms and the y terms separately. In this case, we'd add 4 to both sides to get this to the other side. So these are equivalent expressions. I've done some rearranging, and I've added 4 to both sides. Okay, then I take -2, which is this number, divided by 2, and I square it. -2 divided by 2 is -1. -1 squared is +1. So I add 1 here. As a consequence, I have to add 1 on the right-hand side. Here I take 4, which is this number, divided by 2. 2 is, we always divide it by 2, doesn't matter what we square it. 4 divided by 2 is 2. 2 squared is 4. So I add 4 here, and so I add 4 again. So then I can rewrite this as x squared minus 2x plus 1 plus y squared plus 4y plus 4. And if you add these numbers together, you'll get 9. 4 plus 1 is 5. 5 plus 4 is 9. Remember, you take these numbers, the ones in the parentheses, which I forgot to put a parenthesis here. So this can be rewritten as x minus 1 quantity squared, using that -1. This can be rewritten as y plus 2 quantity squared. That equals 9. So here I'm just rewriting these quadratic terms as a complete square. So now that it's in standard form, I can say the center is at x equals +1. This has to go to 0, so 1 minus 1 is 0. And y equal to -2. So when y equals -2, this goes to 0. And the radius is equal to 3, which is from the square root of 9. So that's the answer.